This is the sort of thing you're most likely to see when it comes to dealing with circles algebraically. You're going to see a formula, and then you're going to see a question asked about those types of circles. In particular, one thing that I've seen asked a lot on ACTs is, given some information like this, some formula for a circle, some equation that is represented by a circle, if you will, then it'll ask a question like, what is the area of this circle? So, with that in mind, there are a lot of ways you could approach it. You could graph the whole thing. You could try to figure it out. But really, if you think about it, you already know this is a circle that's centered at these points indicated by those and has a radius equal to the square root of this constant over here. So by the time that you know that this circle has a radius of 5, you actually have every piece of information you could possibly need to answer the question in the first place. Let's do it. If the radius is 5, then the area of a circle is equal to pi times r squared, which means the area of this circle will be equal to pi times 5 squared, or pi times 25, or 25 pi. If you wanted to get a decimal equivalent of that, you totally could. You could also do it in your head. 3 times 25 is right about 75. But 25 pi is probably going to be the answer you'd see on a multiple choice test. Pretty straightforward, pretty simple. Some other things you could do to challenge yourself is you could make sure that you could find the circumference of a circle that was that size. Other things that you might want to be able to do is make sure that you can find the center of that circle. The last one that you might be expected to know would be like, which of these points is the highest point in the circle, and that one requires a little bit more critical thinking. I'll run through it so you kind of have a way of imagining what